Catalysis. So a catalyst is a substance that speeds up a reaction without being consumed itself. So how does it work? It lowers the activation energy. So our first line is the red line, which is the uncatalyzed path. You might remember that the line from the base of your reactants to the top is your activation energy. Then, if you add a catalyst, it lowers the activation energy. So now our activation energy is much smaller. A homogeneous catalyst, or catalysis if you would like, is just present in the same phase as the reacting molecules. If you have gases, your catalyst is in the gas phase as well. Heterogeneous, you just have it in a different phase. Usually a solid is what we see. A catalyst makes the reaction have more effective collisions. So the other graph that I wanted you to understand is here's the number of collisions on the vertical axis this time with our energy on the horizontal. There's our activation energy. And any of the molecules that are on this side under the curve have enough energy to collide and have an effective collision to make the product. If you add a catalyst, it lowers that energy, and now you have more molecules that have enough energy to have an effective collision. A heterogeneous catalysis, what usually happens is you have a gaseous reactant adsorbed, yes, it's adsorbed, on the surface of a solid. I'll show you a diagram in just a second. And then absorption is the collection of a substance on the surface of another. So one thing they use it for is to change ethylene to ethane. So notice there is a double bond between the carbons here, and by using a catalyst, they can change it to a single bond between them, and it has to react with some hydrogen to get enough hydrogens around the carbons. So here's what happens. You have your hydrogen and your C2H4 with a double bond between the carbons. You have a metal surface. This is usually where you see your precious metals, like platinum or rhodium or something like that. The hydrogen is adsorbed, so it goes to the surface, and it breaks the hydrogen-hydrogen bond. And there's that pi bond in ethylene. You might remember the pi bond is the one when you have a double bond, you have your sigmas in the plane, and then the pi bond is perpendicular to the plane of the atoms. That bond is broken, and then the absorbed molecules in the atoms migrate towards each other, and you form that new carbon-hydrogen bond. So you have 3 hydrogens around your carbon, and then the bond or the carbon in C2H6 is saturated. It can't bond to the metal and therefore escapes. So you have all single bonds when a carbon is saturated. Catalytic converters is everyday use of catalysts. So we always have a reduction and an oxidation. So your redox reactions occur. First you have the reduction occurring, forms oxygen, and the oxygen helps to form the oxidation reactions.